A very good morning to one and all present here. Today we are going to see about the iron carbon phase diagram. It is defined as the map of temperature at which the different phases changes occur on a very slow heating and cooling in relation to carbon content is isothermal and continuous cooling transformation diagram for a plain carbon and alloy steels. The iron carbon diagram shows the type of alloys formed under slow cooling, proper heat treatment temperature. The properties of steel's cast irons can be depend on changed by the heat treatment. In the simplest form, steels are the alloys of iron and carbon. The percentage of carbon between 0 to 6.67, because 6.67 percentage carbon is the maximum ratio of carbon can be dissolved in iron. After 6.67 percentage of carbon, all metallic ions are non-important alloys in engineering application. Iron contains 0 percentage to 1.7 percentage of carbon, known as steel. Steel contains approximately 0 to 0.83 percentage of carbon, is known as hypoeutectoid steel. Consists of primary ferrite and pearlite phases. Eutectoid steel contains the carbon of 0.83 percentage, entirely consists of pearlite. Steel contains below 0 to 0.83 percentage of carbon is known as hypoeutectoid steel. Then the steel contains 0.83 percentage to 1.7 percentage of carbon, known as hypereutectoid steel. Consists of a primary cementite and pearlite phases. The iron contains carbon more than 1.8 percentage is known as cast iron. In the iron carbon diagram, the room temperature to 912 degrees Celsius was a stable called as ferrite stage. It was ductile but very strong stage. After 912 degrees Celsius to 1395 degrees Celsius, the structure transformed to a face centered cubic structure, a new phase called austenite. From 1395 degrees Celsius to 1539 degrees Celsius, the structure transformed to a body centered cubic and a new phase called ferrite. After 1539 degrees Celsius is the melting point of iron. After this degree, the iron transformed to a liquid phases. In this diagram, there are three horizontal lines are shown. The first horizontal line is about 1493 degrees Celsius, in which where the protective reaction takes place, liquid plus delta form the austenite. In the second horizontal line is about 1130 degrees Celsius to 1147 degrees Celsius, where eutectic reaction takes place. Liquid stage is austenite plus cementite. Then the third horizontal line is at 723 degrees Celsius, where eutectoid reaction takes place. Austenite and pearlites are formed. In the phase diagram of iron carbon, the structured forms are ferrite, pearlite, cementite, martensite. Like this, there are various structures can be formed. In this slide, we can see about the what are all the structures which have been formed at the what are all the temperatures and what are all the transformations happened in the iron carbon phase diagram. In this PPT, we have seen about the what are all the transformation structures occurred, like austenite, cementite, pearlite, ferrite and austenite, ferrite. At the temperature, the transformation will happen, and the microstructures of the transformation also seen in this phase. Next, in this PPT, we can see about the what are all the solutions stages occurred in the iron carbon diagram, like solid solution of a carbon and liquid solution of an pearlite, cementite, hypoeutectoid steels are formed has been shown. And in this phase we can see about the micro constituents of iron carbon alloys. First one ferrite, next one perlite, third one austenite, fourth one cementite, fifth one leadbrite, sixth one martensite, seventh one trucite, eighth one sorbite, ninth one bayanite. Ferrite is an alpha solid solution. It is an industrial solid solution of a small amount of carbon dissolved in alpha BCC carbon. Stable form of iron below 912 degrees Celsius. The maximum solubility is 0.025% of carbon at 723 degrees Celsius and dissolves only in 0.008% of carbon at room temperature. It is the softest structure that appears in the iron carbon diagram. The ferrite structure, the tensile strength is 40,000 psi and the elongation is 40% in 2 inch. Hardness is B90 in Rockwell. Next structure we have been seen about the perlite. It is an eutectile mixture containing 0.8% of carbon and it is formed at 722 degrees Celsius on very slow cooling. It is a very fine plate-like or a lamellar mixture of ferrite and cementite. The white ferritic background or matrix contains thin plates of cementite which is dark in nature. The average properties are the tensiles are 1,20,000 psi, elongation is 20% in 2 inch and the hardness is 95 to 100. The next structure we have seen about is austenite. It is an industrial solid solution of a carbon dissolved in gamma FCC ion, face-centered cubic ion. Maximum solubility is 2% carbon at 1130 degrees Celsius. High formability. Most of the heat treatment begin with this single phase. It is normally stable at room temperature, but under certain conditions, it is possible to obtain austenite at room temperature. The average properties of austenite are tensile strength is 1,50,000 psi, 10%, elongation is 10% in 2 inches, hardness is C40. Toughness of this austenite structure is very high. Next structure we have seen about is cementite. Cementite or iron carbide is a very hard, brittle, intermetallic compound of iron and carbon as Fe3C. It contains 6.67% of carbon. It is the hardest structure that appears on the diagram. The exact melting point is unknown. It has low tensile strength and high compressive strength. Next is leadbrite. Leadbrite is the eutectic mixture of austenite and cementite. It contains 4.3% of carbon and it is formed at 1130 degrees Celsius. Next, martensite. It is a supersaturated solid solution of carbon in ferrite. It is formed when the steel is cooled so rapidly that the change from austenite to perlite is suppressed. The industrial carbon atom distorts the BCC ferrite into BC's tetragonal structure responsible for the hardness of quenched steel. That's all. Thank you.